I will go through how to calculate the wind load. Wind load is the external pressure or suction of wind force is calculated using the following equation according to ASCE 7, American Society of Civil Engineer. How can we calculate the wind load on any building? We have two steps. The first step, we need to calculate first what is the fluctuating pressure, and then what is the wind pressure. But let me explain something for you. If you have a house or if you have warehouse like this, a building like this one, and here is the direction of the wind, I need to remind you for something. Probably I covered it last year in structure analysis course, probably. This direction or this side of the building, which is opposite to the wind direction, can be called windward direction. The other side called leeward direction. This one can be called side direction, and this one can be called side direction, and the top of the building can be called roof direction. The wind value or the wind pressure on this side will be constant value, constant value, constant value, constant value. Only one value. Not all of them are equal, but I'm talking about the whole side. The wind force will be constant. For the windward direction, probably your wind load will be variable. Smaller at the bottom and became bigger and bigger at the top. Okay, this one will be under compression. This leeward direction will be under suction. The roof will be under suction. This side under suction and this side under suction. So if you watch this video about the effect of the wind load, you can understand which side is under suction and which one is under compression. Let's do it. So this is the side of the windward. It's under compression. Under compression. So the building is moved in the same direction of the wind. This side is under compression. That makes sense. Can you watch the top of the building? What's going on? This roof is under suction. So it's going up a little bit. Can you watch this side or this side? It's under suction, not under compression. Under suction. This side, suction. every part coming up. I'm sorry, coming out. So the roof is under suction. Can you watch what happened to the roof going up? So as I told you, this side will be windward wall. This one, windward under compression. This one leeward, because the wind direction is coming from this side. Leeward is under suction, the roof under suction most of the time, and the side will be under suction. How can I calculate the wind pressure? We have two steps. The first step, we have fluctuating pressure value, QZ equal 0.00256 kz kzt kd v square. Kz is the velocity pressure exposure coefficient, which is a function of height based on this table. What is the height of the building? I can give you what is the value of Kz. Kzt is a factor that accounts for wind speed increases due to hills. If you have mountains, if you have kind of terrain, then we can figure out the value of Kzt. However, if you have a flat terrain or flat ground, your value will be 1. So most of the time, I'm gonna use Kzt as 1. Kz from this table. Kd is a factor that accounts for the direction of the wind. For wind acting alone, without earthquake, without anything else, Kd will be 1. So Kd most of the time will be 1. V is the velocity of the wind speed, mile per hour, depends on the type of the structure and the location. I'm giving you this link. If you open it, good morning, Ihab. If you open it for wind, put your address. I'm gonna put commerce, probably 75428. This table can give you the speed of the wind mile per hour based on the risk category. Risk category depends on the type of the structure. If you are building buildings for university, for schools, for hospitals, for residential building, we have different type of risk categories. Anyway, so I can figure out the velocity of the wind, mile per hour, which represent V. Depends on the type of the structure. Type of the structure can determine the risk category. Location of the building, you need to put where is your building, which city, which location. So I can give you a value for the velocity. So if you are looking for what is the value of V, you need to use this link and define where is the building and what is the risk category based on the type of the structure. This link can give you the velocity mile per hour. So the final conclusion, 0.00256 time kz time kzt time kd time v square. Finally, I can get the fluctuating pressure of the wind. Once you get it, I can calculate the actual pressure of the wind by this equation. Q times G times Cp minus QH times G Cpi. This wind pressure is a surface load, the final load. Q equal QZ if you are talking about windward wall. Q equal QH if you are talking about leeward wall. G is a wind gusset effect factor is taking like 0.85. So this value 0.85. Cp wall pressure coefficient based on this table for windward wall Cp equal 0.8, leeward wall equal these values based on the relationship between L divide B. L is the length, the width of the building. B is the length of the building. For side wall, the value for Cp equal negative 0.7. Anyway, GCPI is the internal pressure coefficient. All the time is taken as plus or minus 0.18. How can we use this wind pressure equation? How can we use these two steps to calculate the final wind pressure? I'm gonna do it using this example. So please pay attention to me. How can we use this method to calculate the wind pressure? Just a second. Okay, we have enclosed building shown in the photo is used for storage purposes and is located outside of Chicago, Illinois, in open flat terrain. When the wind is directed as shown, this direction, determine the design wind pressure acting on the roof sides of the building using ASCE 7 specifications. First step, I'm gonna calculate the fluctuating pressure. This one. What is the value of QZ? Equal 0.00256 KZ, KZT, KD, I think, V square. One by one. 0.00256 KZ is variable. KZ tube will be 1, KD will be 1, V square. I need to go to Chicago to figure out what is the velocity of the wind. So do you know Chicago, Illinois? Okay. And I'm gonna assume the building is risk category 1. Actually, we should have another table from ASCE based on the building type used for storage purposes. So this function of the building will help you to figure out what is the category of this building. So I'm gonna assume my building is risk category 1, so the velocity will be 100 mile per hour. 100 mile per hour, so this value will be 100 square, V square. So the final value for the fluctuating pressure as a function of KZT will be 25.6 kZ. This is the value of kZ. The second step, what is the wind pressure? We have equation P, wind pressure equal Q time G, I think, times CB minus QH time GCPI. One by one, step by step. QH is the value of QZ at the mean height of the building. I'm sorry, what you mean? What is the height of this building? Can you tell me what is the height? Is it 25? This is the height of the building, 25? I don't think so. Your building looks like this. This length, this height, this angle. 10 degree, I think. And 75, 75, 25. This one is 25. This one is 75, 75. So, can you tell me what is the height here? You can set up this right angle triangle. This angle is 10. This length is 75. So 10 equal this height y divide 75. So I can figure out the value of y. It will be 10 times 75. It will be 13.2. So the mean height h equal this height 25 plus the mean height for y 13.2 divide 2 equal 31.6. So if you are looking for the height of the building, because this building has a sloped roof, I'm gonna measure the height of the building from the base to the main height of the sloped roof. 25 plus this height, y divide 2. So the height will be 31.6. The value of QZ equal 25. What is the value of QZ? 25.6 KZ. If you are looking for QH, the height of H equal 31.6 feet. 31.6 feet, that means the value of KZ equal 0.98. The value of QH will be 25, probably 0.1. So the value of QH in this equation equal the value of QZ at height H. So I will use this table at height H equal 31, so I'm gonna assume it's 30. The value of KZ will be 0.98. I will use it with QZ to figure out the value of QH. This is the first step to figure out this value. The value of G is 0.85. The value of GCPI equal positive or minus 0.18, I think. Yes. I'm still looking for what is the value of Q, what is the value of CP. It depends. If you are looking for wind, ward, wall, which is the front of the building, I can say P, the pressure of the wind, equal QZ time 0.85 time CP, the value of CP for wind, ward, wall equal 0.8. Minus QH, which equal 25.1 time plus or minus 0.18. For elevation 0 to 15, KZ equal 0.85. So QZ will be 25.6 times 0.85. This value equal 21.76. So your final pressure from 0 to 15 equal 21.76 times 0.85 times 0.8 minus 25.1 times plus or minus 0.18. This value, you will have two values because we have plus or minus. 21.76 times 0.85 times 0.8 minus 25.1 time 0.18. This value will be 10.27 pound per square feet. This is the minimum value. The maximum value will be 19.3 pound per square feet. If you are talking about the next or the following height from 15 to 20, so pressure or I will say at height 20 feet, QZ equal 25.6 times KZT at this height equal 0.9. 25.6 times 0.9 equal 23.04. So the pressure at this height 20 feet equal 23.04 times 0.85 times 0.8 minus 25.1 times plus or minus 0.18. Your final answer, we will have two values, one for positive and one for negative. 0.85 times 0.8 minus 25.1 times 0.18, 11.415 pound per square feet, and 20.18 pound per square feet. The next height to 25. So at height 25 feet, KZ equal 25.6 times KZT. At this height, it will be 0.94. So 25.6 times 94 equal 24.06. So pressure at 25 feet equal 24.06 times 0.85 times 0.8 minus 25.1 times plus or minus 0.18. You will have two values. The first one will be 11.8. The second one will be 20.9 pound per square feet. Pound per square feet. At height 30, QZ equal 25. What is the value here? 25.1. And then your pressure at 30 feet equal 25.1 times 0.85 times 0.8 minus 25.1 times plus or minus 0.18. You will get two values. So 12.6. The second value 21.6 pound per square feet. pound per square feet. So here is the windward wall of the building. From 0 to 15, we have a value of pressure. How much? I will use the maximum value, the highest value, 19.3 pound per square feet. From 15 to 20 feet, we have another value, 20.18. 20.18 pound per square feet. From 20 to 25 feet elevation, your pressure equal 20.9. To the average height of the building, which is 30 feet, your value will be 21.6. Here is the values of the wind pressure on the windward wall of the building. If you are talking about windward wall. The second one, leeward wall of the building. Cody, this point is very important for the roof height. I will not consider the total roof height. I will consider the average height, because it doesn't make any sense to take this point. Doesn't make any sense to take this point. So I will use the average one. This point is very important, okay? The average height. So I will not use 25. I will not use the total height. I will use the average height for the sloped roof. Okay? Okay. For leeward wall, the wind pressure will be QH GCP minus QH GCPI. That's it. Remember, for this equation, Q equal QH, this term equal QH if you are talking about leeward. So we will have only one value. QH equal, do you remember that? I calculated QH at the beginning, 25.1. 25.1. What is the value of G? 0.85. What is the value of CP? CP for leeward, we have three different values. Depend on the relationship between L and B. L, the parallel to the wind direction. B, the perpendicular to the wind direction. So this building looks like this. This length equal 150 feet. This length equal 150 feet. Here is the direction of the wind. So here is L, here is B. By the way, L divide B equal 150 divide 150 is 1. So if the relationship or the ratio L divide B between 0 and 1, your value will be negative 0.5. So this value CB will be negative 0.5 minus QH 25.1 times GCPI plus or minus 0.18. So we will have two values for P of the leeward wall. We have only one value, constant value. So 25.1 times 0.85 times negative 0.5 minus. Let's start with the minus one. 25.1 times 0.18. This one will be negative 15.2 pound per square feet. Negative means suction. That makes sense. I will use the other sign to get another value. 25.1 times 0.85 times negative 0.5 plus 25.1 times 0.18. We have negative 6.15 pound per square feet. I'm sorry, this one is square. So here is the building. The wind direction is coming from this side. I'm talking about the leeward. This one, we will have suction value. How much? I will use the maximum value, 15.2 pound per square feet. Suction. This is for leeward value. For roof, the value of pressure equal QH also GCP minus QH time GCP I. So 25.1 times G.85. What is the value of CP if you are talking about the roof? Where is the roof? The roof. Here you go. This one for roof. Based on the angle. For angle equal windward angle for the roof 10 and normal to the ridge H divide L. H is the average height and L is the span. Let's do it. The average height was 31.6. Divide L, which is 150. So 31.6 divide 150. It will be 0.21. 0.21. I think you are here. This one. Windward angle. Windward. Negative 0.7. Negative 0.7 minus 25.1 times positive or minus 0.18. So guys, to make sure I'm talking about, there is the wind direction. Right now, I'm talking about this windward roof. I'm talking about this value. So I will get two values based on negative and the minus here. So 25.1 times 0.85 times negative 0.7 minus 25.1 times 0.18. We will have negative 19.5. We will have another value. negative 10.4. So I will use the maximum value. So your value here will be negative 19.5 pound per square feet. This one is windward. If you are talking about leeward roof, which is the other side of the roof, here is the wind direction. So right now I'm talking about this value of the roof. So your pressure equal 25.1 times 0.85 times CP. The CP value for leeward angle 10 and H divide L smaller than 0.25, negative 0.3. Plus, minus QH time plus or minus 0.18. So we will have two values. Negative 10.9, and we have another value which is a smaller value, negative 1.9. So this value will be negative 10.9 pound per square feet. So the final conclusion for this problem, we have a building, looks like this. In this direction, from 0 to 15, from 15 to 20, from 20 to 25, we have three values like this. Do you remember that? Go back. Yes. We have 19.3. Then we have 20.18. Then we have 20.9 pound per square feet. For the leeward value, it's a suction. We have only one value for this side. How much? 15.2 pound per square feet. For the windward roof, which is this one, we have a value 19.5 pound per square feet. For the leeward roof, we have a value 10.9 pound per square feet. This shape can show you the wind pressure on the building. Actually, the only one will need more calculations is the first one, windward, because we have different values at different height, from 0 to 15, then at 20, then 25, and so on. So the final values for wind pressure must be looks like this. For the wind ward wall, lee ward wall, wind ward roof, lee ward roof. Any question? Yes. all directions are constant. All directions are constant, has a constant value, except the windward. We need to calculate at each elevation. How can I figure out these elevations? Based on this table, because we have different value for KZ at different locations. The first one from 0 to 15, then 20, then 25, and so on. If your building, the height is greater than 30, okay, we will do also at 30 and 40 and so on. So the only variable values for the windward, we have different values at different elevation, but any other side, constant values. Guys, these values are pressure. Pressure means surface load. Do you remember that? And this surface load on this side of the building. This surface load on this roof surface. On the corrugated sheet. Surface load. How can I convert this pressure to each main system? If your main system looks like a truss, like this, how can I convert this pressure to this truss only one of the main system? For this building, we have only here one truss. We have one truss, you know? So how can I convert, or how can I get the value of the wind load assigned only to this truss? It's very easy. If you have a truss, you will have here concentrated load at each joint. This concentrated load is perpendicular to the truss surface. What is the value of this one? Equal this value of wind pressure, 19.5 times S times A. Do you remember that? S, we have a truss, we have another truss. We have another truss which you call the main system. The S is the spacing between the main system. A is the spacing for the vertical member of the truss. A. So if you multiply the wind pressure value by the spacing between main system and the spacing A, you can convert this wind pressure to concentrated load at each joint. Make sure these concentrated load are perpendicular to the surface of the truss. What is the value for this concentrated load? Okay, your pressure, your wind pressure, 10.9 times S times E. This wind pressure will be the same here as line load equal these values, 20.9, 20.18, and 19.3 times S times S times S as line load only on this column of the truss. This one is surface load on the side of the building. So I converted this pressure to only line load. line load on the column of the truss. We have another line load here, which is suction. How much? This pressure 15.2 times S. So guys, after you calculate the wind pressure, this wind pressure must be multiplied by S time A, not A prime. No, it's A because it's a horizontal projection. Time A to convert it to concentrated load at each joint. Make sure this concentrated load is perpendicular to the surface. For the side windward or leeward, we need to convert the pressure of the wind to line load. So I will multiply it by S only. So the final shape of the truss or the main system under the effect of wind looks like this. Concentrated load at each joint for the roof and uniform or line load at this column and this column. It's complicated a little bit, but wind is very important. We have to consider the effect of wind. So this example is very important. I solved it step by step. Your steps is very simple. Your steps are very simple. The first step, what is the fluctuating pressure? QZ. QZ will be a function of KZ. Then the wind pressure, we have this equation. To use this equation, we need to figure out which part you are looking for. I will start with windward, then leeward, then for the roof, we have two parts of the roof. Windward roof has a different value of CP, and then leeward roof, we have another value for CP. Once you are done, the final values of the wind pressure looks like this. Exactly. We need to convert this pressure to forces on the truss as a main system. For this column and this column, we need to multiply these values by S. For these values on the roof, I will multiply them by S times A to convert them to concentrated loads. Okay? For snow loads, probably in Texas we don't have snow, but in different states we should have snow. If your roof is flat, like a building, flat like this. There is a building, so your roof looks like flat. The value of the snow load P flat equal 0.7 times CE times CT times IS times PG. CE exposure factor, we have three terrain categories B, C, D. We can figure out the value of CE from this table. So, for example, if your terrain category is C and the roof is fully exposed to snow load, your value will be 0.9. All of this information will be given in the problem. If your terrain category is B and the roof is partially exposed, your value will be 1. IS is the importance factor. Based on the risk category, for example, if the risk category of the building is 2, the importance factor for snow load will be 1. Here is the value of IS, importance factor for snow. So based on the risk category and this table, I can figure out the value of IS. CT, thermal factor. Based on what's going on with the structure during freezing or heating, we can figure out the value of CT. For example, if the building or the structure is unheated and open air structure, we have many opens, so the wind can get in the building and we don't have heating system in the building, so your value will be 1.2. So based on this table, I can figure out the value of CT, the value of CE, the value of IS. So finally, what is the value of PG? We have here the map of the United States. So we need to figure out the value of PG. Where is Texas? Where is Commerce? I think Texas is here, probably. Yeah, this area, I think. So you have a different value. Which city? Probably Dallas area. So your value here will be PG equal 10. Okay. If you are looking for Chicago, for example, this one, your value will be 25. So the value of PG is located on this map based on the location of the city or the location of the building. I can figure out the value of PG. Ground snow load, PG. So this equation will help you to figure out what is the value of the snow on the flat roof as pound per square feet. Pound per square feet. CE, exposure factor from this table. CT, thermal factor from this table. IS, importance factor from this table. PG, snow ground load or ground snow load. Based on this map of the United States, I can figure out the value of PG based on the location of the building. If you multiply these values together, you can get the snow load PF on flat roof. Does that make sense? That makes sense? Also, these snow loads based on American Society of Civil Engineers 7. What will happen if you have sloped roof like this one? It's easy. Just get the flat roof value of snow that you calculated from this equation and multiply it by a factor called CS. This factor can be found from this chart or this chart or this chart based on the value of CT. Based on the value of CT, I can use this one if the CT smaller than 1, if the CT equal 1.1, if the CT equal 1.2, and based on the roof slope, what is the angle theta for this roof slope, I can go up to hit this solid line, then I can figure out the value of CS. Based on the slope angle, I can hit the value of the CS. Multiply CS by BF, I can get the snow load on sloped roof. Once you are done, I need to convert this snow load from surface load to concentrated load at each joint of the truss. So you need to multiply BF or PS. BF if you have flat roof, PS if you have sloped roof, by A times S, then you can convert this snow load to concentrated load at each joint. So guys, if you go back to the previous meeting, we can convert the dead load of the building to concentrated load on the truss, the life load of the building to concentrated load on the truss. Today, the wind load to concentrated load on the truss. Snow load to concentrated load on the truss. So the final, we have a truss under the effect of dead load, wind load, life load, and snow load. We need to analyze this truss using RISA 2D. I will go through this step next week.